privacy and ethics are fundamentally different things. Just because you're doing things privately doesn't mean that it's right.
Welcome back to Evolving, the podcast designed to help you strive, thrive, and optimize. Today, I'm joined by Dr. Rand Hindi, a deep tech entrepreneur and investor. He is the CEO of Zama, an open source homomorphic encryption company dedicated to democratizing privacy. He is an investor in over 30 companies spanning privacy, AI, blockchain, medtech, and psychedelics. He previously created Snips, an AI startup that was acquired by Sonos, and now powers the voice assistant in over 20 million devices. Today, he joins us to talk about privacy, cryptography, bioinformatics, investments, and his predictions for the future. Dr. Hindi, thank you so much for being with us.
Hi, Nita. Thanks for having me. Rand is fine, actually. Dr. Hindi sounds way too formal.
Understandable. So, cryptography has a really rich and storied history, from the Zimmerman telegram in World War I to radio frequency hopping and the Enigma machine in World War II, all the way up to the development of RSA in the 70s. But you have a very personal connection with encryption that stems all the way back to your days as a student in grade school when you were dealing with a bully. Take us back to that moment when you first realized that privacy was extremely important.
Right. I mean, I started coding when I was 10 years old. And as a teenager in the 90s, a friend of mine and I basically started a social network, like a website where people could just post pictures, have conversations. Like it was end of 90s, so it wasn't something huge, but it was quite popular amongst teenagers in Paris. At some point in school, a very tall, older guy started to bully me. And I really couldn't do much. Like I was 14, he was like 17, so I couldn't physically defend myself. So I started thinking, maybe he's a member of my social network. And maybe if I dug into his private messages, I could find something incriminating enough that I could hold against him. And so I did, and I did find something. And the next time he came to me, I told him about that, and he left me alone. And you could argue, well, bullying a bully is fair, right? It's justice. But I couldn't shake that feeling that I had done something fundamentally wrong. Just because I was operating this social network, just because I was the creator, didn't mean I had a right to people's privacy, right? And so from that day, for me, it became obvious that the internet was broken unless we could fix privacy. And that's why everything I've built since then, from my AI company to my current company to things I invest in, are privacy related.
So you envision a future where privacy won't matter anymore, not because it isn't important, but because it would be guaranteed by design in the internet itself. And Zama has a great graphic illustrating this, where we used to have hypertext transfer protocol, HTTP, where there was no encryption at all. Everyone can see everything. And then we migrated over to HTTPS, where data is encrypted when it's sent, but not during processing. And you envision HTTPZ as the homomorphic equivalent of this, the next iteration where data is encrypted end to end all the time. And you also talk about an interesting application of this where even advertising would be encrypted. Explain to us how this model would work.
The idea of homomorphic encryption is that you can basically do processing on encrypted data without having to decrypt it. So another way to put it is a company can provide a service on its users' data without actually seeing the user data they're analyzing for the user. So it sounds a little bit crazy. It's like kind of like this magic black box where you send in gibberish, it sends back gibberish, but when you decrypt it, you actually get the correct result. So this is something you can apply to anything, to blockchain smart contracts, to, artificial intelligence, and to advertising. So the idea of advertising here is that, let's imagine a social network wants to run some targeted ads against your profile. Instead of having your profile, they would have an encryption of all of the data in your profile. So it doesn't know your name, it doesn't know your address, it doesn't know your age, all that is encrypted. But because they've encrypted it using homomorphic encryption, they could still run pattern matching algorithms, right? So they can still say things like, find me all the user who are between 18 and 25 living in New York, for example. And the response they get will also be encrypted. So they actually don't know who those users are. They just have a list of random people from the social network whose encrypted profile correspond to that. And they can then effectively, suggest ads to those users. So those users would see those ads as if everything was normal, but the social network that did the matching wouldn't actually know who got those ads. And then for attribution, because you got to pay people eventually, you can just add an attribution link. If the user clicks on the link, then he's identified, of course. If the user doesn't click on the link, everything stays private. And so you can do that for anything. And so the vision we have here for this HTTPZ is that by providing tools to developers, eventually everything they build will be encrypted end to end. And therefore, your browser will be able to take care of that for you. And as a user, you'll be oblivious to what's happening.
Brilliant. So, my understanding of homomorphic encryption is that data retains some underlying structure as though it's translated into a language that we don't quite know how to speak, but it still has syntax, it still has structure, and that's why you can still perform processing on it. In your view, what are the latest advancements in standard homomorphic encryption, and how do we get to a point where we can process it at a speed that makes it feasible for daily use?
The problem with homomorphic encryption used to be, well, first that it didn't work. You couldn't really do much with it. You could do some addition, some multiplications, but you couldn't do like deep learning. You couldn't do any complicated computation. That is something we solved already. You can do arbitrary computation and encrypted data today. There is no more limitation on that. The second problem is that it was too hard to actually be useful for developers. So unless you had a PhD in cryptography, there wasn't much you could actually use here. So we've solved that as well by creating developer tools that abstract away all of the complexity of homomorphic encryption so that anybody who can write code can start using it. And finally, the last mile is performance. How can we make this technology fast enough that you can deploy that in every cloud or blockchain use case that you might want to run privately? And for this, there is a combination of better mathematics. So you need to do research. So we're inventing new ways of doing homomorphic encryption and ways of improving existing homomorphic encryption techniques to go faster, but also putting a lot of effort on hardware acceleration. So having dedicated processors that are going way faster than your CPU or GPU in order to do this cryptographic processing much faster.
Brilliant. In 2015, you gave a TED talk where you proposed a potential solution to phubbing or phone snubbing, that behavior where we ignore people in our immediate surroundings by instead paying attention to our phones. You made a prediction that by 2025, there would be 100 billion connected devices, and you talked about how a specific type of AI called context awareness would make technology disappear by eliminating the friction of endless notifications. And you even have a name for this era called ubiquitous computing. And the main idea is that technology will add value instead of friction. You reference the history of electricity and how bumpy the road to widespread adoption was there. But just as electricity matured, it became more accessible and more ubiquitous. And now it's just so integrated that we don't even pay attention to it. In a similar vein, ubiquitous computing, in your view, is about enjoying the world in a way that feels unplugged, yet provides all the benefits. How close are we to the era of ubiquitous computing?
When I started talking about that a few years ago, I was really only thinking about connected devices in the context of how we use them day to day. But I think since then, my thinking has shifted a little bit that it's not just about how machines interact with human. It's about how machines and human kind of merge into this sort of new species, right? So how does technology and biology gets intertwined in a way where they become indistinguishable? And the first thing you need in order for that to happen is for technology to be safe. And that's why I'm also so interested about privacy is that if we want to trust technology, we have to make technology safe, safe, in terms of not dying, but also safe in terms of not feeling exposed whenever we use it. And so I think, there is a broader sense that the way that we can go faster than biology is through technology. And making technology disappear is actually a metaphor for that, right? It doesn't literally disappear. It's just that you can no longer distinguish it from biology. It just becomes the same thing. So it's very related to ideas around singularity and transhumanism, but with a little bit less of a churchy feeling, I would say.
Gotcha. Just going back to your reference to biology, given your bioinformatics background, I wanted to talk a little bit about AlphaFold's recent unveiling of their database of 200 million protein structures. And from biology, we know that structure determines function. One of the most commonly used examples to illustrate this point is the fact that red blood cells, in humans at least, don't contain nuclei, the reason being that they're able to carry that much more oxygen via the protein hemoglobin. But what do you think this milestone means for the future of biology? Do you see this as potentially shining light into prion diseases where misfolded proteins are implicated, potentially having a use for neurodegenerative disease like Alzheimer's, where you see the buildup of beta amyloid and tau tangles? What do you envision will be the insights that we glean from this expanded knowledge of proteins?
It's really huge. Actually, protein folding is what I worked on during my PhD 15 years ago. So, AlphaFold would not have been possible back then, but we were thinking about using machine learning, and there were some early experiments, nothing conclusive, quite frankly. I think we didn't have the power or the techniques to make it happen. It is a big breakthrough. I think it's probably one of the biggest breakthroughs in terms of direct applicability, because if you're able to predict the structure from, the DNA, from the genes, then you can also predict how mutations will affect the protein structure and therefore how that will affect the binding with other proteins or with different drugs and things like that. And this is really, really important. It's important for designing personalized medicine, right? You need to know exactly how those things are going to interact. It's important for understanding disease. It's important for understanding just protein engineering in general, right? Code a sequence, see what it looks like, figure out whether it does the kind of stuff you want it to do. Much easier if you have a simulation, if you have to actually build it and test it in the lab afterwards. So I think, it opens up a new era of computational protein design, which was not possible before.
Going back to your mention of personalized medicine, when I served on the board for a clinical trial, one of the things that we talked about was how to privatize the collection of health data. And, there are certain demographics that have very valid reasons to be a little hesitant to share their information, especially when you look at cases like that of Henrietta Lacks, for example. How do you envision homomorphic encryption changing healthcare? And what new abilities will we be able to gain when privatization is guaranteed?
That's a very good question. And I think homomorphic encryption is, quite frankly, the solution to that problem because it would give you the opportunity to not share your data directly, but share encrypted data that could be used for analysis. But they wouldn't know that it's your data. They would just know that someone contributed encrypted data that corresponds to what the researchers needed. So again, same thing as with advertising. You could filter, population medical data based on some criteria that you want to include in your study, but you wouldn't actually see the data. You would still get like an encrypted list of attributes for every one of these users. But then you can run your statistical algorithms on it. You can run machine learning algorithms on it. And the results could be used for, building something else, even though you have, nothing about the individual inputs and data contributed. So I think, the reason why people are afraid of contributing data to medical research isn't because they're worried the scientists will leak it, right? Is they're worried this data will get stolen and leaked online, which has happened recently quite a few times. And so homomorphic encryption makes it such that even if the data was leaked, nobody could decrypt it. So nobody could know anything about you as an individual. All they could do is do processing on it and transform it into something that would only make sense in aggregate, not individually.
That's brilliant. And this kind of reminds me of another part of some clinical trials whereby sometimes there is monitoring done just in case a trial needs to be stopped early. And
Yep.
could that also be programmed such that if one arm is experiencing significantly disparate results compared to the other, that researchers would still be informed of that abnormality?
You could, yeah. Effectively, what you're doing is you're basically building a system that decrypts the data if there is some specific condition. Yeah, you could do that. In fact, actually, we do that quite often. For example, if you want to authenticate someone using facial recognition, so you have a database of encrypted facial patterns. So you would send an encrypted selfie of yourself to authenticate yourself. And only if you are authenticated would the response be yes or no, right? So like the yes or no is not encrypted, but everything else before that is. So it could be exactly the same thing, right? What you're basically saying is, well, if someone has a problem, send me yes or no, there is a problem. And then you go and investigate.
I love that. And just kind of referencing the personal side of medicine, You did once conduct your own N of 1 experiment where you put
Mm.
on 70 pounds just to see if data could help you take the weight off,
Yeah.
and you tracked every aspect of your life in terms of what you ate and drank, how long you slept, and you fed those results into software that determined which behaviors were detrimental. Tell us a little bit about this N of 1 experiment that you conducted and what you found out through that.
Yeah, that was a long time ago. It was fun though. And I've done the other experiment the other way around as well. I actually also experimented on how quickly I could get ridiculously fit. The short answer is you can get fit faster than you can get fat, interestingly, right? I know most people think the opposite, but gaining 70 pounds takes a lot of time because you need to overeat consistently for a long period of time so that your body starts to store all of that. And so it took me a year and a half to gain that weight. And I discovered two things during that. First one is that even though was still myself, as in like I knew I was me, people saw me very differently, right? So there was definitely like a change in perception and a change. My voice was different. My laugh was different because I was heavier. Like everything was different, but my sense of self. So it was quite an interesting psychological sort of like thing. But what I really found out losing the weight again is that it's not just about how much you eat, right? It's not just about low carbs and keto and whatever. It's also about what kind of food you eat. Because if you're eating something that's supposedly very healthy for someone, but that you are intolerant or allergic to, it's not going to do very good to your body, right? You're going to be completely messed up and you're going to, for weird reason, react in weird ways. You're going to be inflamed. You're not going to lose weight. You're going to feel sick. So that was like pretty obvious in this experiment. The second thing also, which was insane, is when you gain and lose weight so fast, your body is in shock. Like it doesn't understand what's going on. It's like, what am I? Am I like overweight or am I actually like fit? And so it takes time for your body to adjust to a new regimen. And so if you're going to go on a diet or if you're going to start working out or if you're going to gain weight, you have to give your body enough time to adapt to what you're doing before going crazy, right? There is such a thing as being overtrained. Well, there is such a thing as being, over dieted. So like all of these things, I think were like pretty obvious. But the bottom line is eat low carb and make sure that you don't eat stuff you're allergic and intolerant to. Pretty much that resulted to that.
Just talking about that point of public perception, do you kind of view homomorphic encryption as preventing discrimination on the basis of factors like BMI or the way that sometimes an insurance company might give higher rates for people with pre-existing health conditions? Do you think that this might prevent discrimination? on-
Unfortunately, not, because homomorphic encryption doesn't prevent you from doing something with the data, right? It just makes it such that you're doing it blindly. So if an insurance company wants to give a rating to someone based on their BMI, they can still do that on their encrypted BMI, right? And that's an important thing. Privacy and ethics are fundamentally different things. Just because you're doing things privately doesn't mean that it's right. And the only way to guarantee that something is right is to, well, either not use a service or have some kind of regulation preventing that kind of stuff. It's fundamentally not going to be enforceable by technology. It's going to be a human thing.
That's a great distinction to make. I wanted to transition a little bit to your investments in medtech. I think you recently invested in Chiperon. Am I saying that correctly?
Well, in French, it's chipiron, but yeah, in English, it's fine.
And they make portable mini MRIs that are smaller and cheaper than traditional ones. And how do you see this as potentially helping with diagnostics or transforming healthcare?
MRIs is interesting because it's a technology everybody wants to use, but that isn't available to everybody. It's costly, it's heavy, it's big, So even in developed countries like France, we have a shortage of MRIs and the wait time can be months before you can actually get an MRI done. So think about developing countries where they have none at all, right? By making MRIs smaller, portable, cheaper, you can put a lot more of them everywhere, right? You're not limited to people who can afford it. And I think that this is something that's going to be really, really important. We're way behind in terms of how much we're using this technology compared to how much we could be using it if it wasn't that expensive.
Gotcha. And what kind of jobs do you think are going to be automated going forward in the future? What are the tasks that we'll be able to outsource to AI?
Well, I mean, anything that's really repetitive and that people don't want to do, right? Something boring and repetitive, just give it to a machine, and do something more interesting. So there are many jobs like that. I did a study like years ago for the French government on that, and we found that only about 10% of jobs in France were fully automatable. About 40% were not really automatable because they're mostly soft skill based, right? But about 50% were kind of half half. And those are the interesting ones because you need to use AI to be more productive, but you cannot ask AI to do all of it itself. And a good example of that, for example, right now is generating content for your social media. You can use GPT-3 to write some text. You can use DALI to generate some images, but you're still going to need a human to write the prompts and to basically select the final result for publication, right? So you still need an art director and, some AI designer to be involved. What has been automated in this case is the actual, drawing or the actual writing. So yeah, it's quite interesting to see how people are using those things right now.
Does that in fact mean that we're going to be seeing more of an age of the generalist versus having these specialized pockets when it comes to skill sets?
That's a good question. I'm not sure. I think we're going to have people learn more and more things over their life. So it's not necessarily they're gonna be generalists at any given point. I think it's just that they're not gonna be specialized in the same thing for their whole careers anymore.
So maybe like a serial specialist kind of
Yeah,
setup.
a serial specialist would be a good way of putting it. I think really what matters here is to empower people to learn those skills as effectively as possible. So I think like that's one of the things that AI is should be particularly good at is enabling people to learn continuously and adaptively depending on where they are in their careers and what they actually know already.
Tell us a little bit about your stance as an Ethereum maximalist and your belief that developers decide what gets adopted.
Mhm. I think I'm a developer maximalist in general, in the sense that I believe the developers are the ones who make important decisions about the future of, the internet and products we use. Because at the end of the day, developers are the one building it. So if developers feel a sense of duty, a sense of ethics, everything we use will be ethical and will be correctly built, right? So I think it's important to empower developers. Ethereum specifically is an interesting community because the developers in Ethereum really want to make this work, right? Like they're very, very strongly opinionated on things like privacy, on things like governance. And so it's fresh to see that there is a whole group of people that are building an enormous ecosystem based on values that were lost on the internet in the past 10 years. So Ethereum feels a lot like the internet of the late 90s as opposed to the internet of the social media era.
Do you believe that the merge will make Ethereum more likely to be adopted on a large scale?
Yes, absolutely. I think the merge was necessary. Aside from pure, like efficiency reasons, just the energetical consumption of Ethereum has now decreased by, 100 folds. And so I think that this was the main bottleneck, I believe, for adoption. You wouldn't want to use a blockchain that's consuming so much energy, right? You would want to use something that's environmentally friendly, and Ethereum became that.
Gotcha. And you had previously mentioned that you often go to Reddit to figure out what people think. Is that still your stance on kind of getting a pulse on what society is concerned about?
Absolutely. Whenever I search for something, I just append Reddit at the end of it. Because I think, if you just search for something on Google today, all you get is basically SEO optimized results, right? Which often are not the real view of people talking day to day. If you go on Reddit, you get the real conversation. And I think, Reddit is still very difficult for marketers to understand, right? It's a community that doesn't have much tolerance for marketing. And so that's why it's been preserved as honest conversations. There's a lot of memes, a lot of trolls, but the content, if you dig through it, is actually authentic. And I like that.
I love that. What do you think about the ability of precision psychedelics to alleviate some of the worst aspects of mental health conditions and also maybe unlock creativity in a way that maybe wouldn't be accessible otherwise?
Psychedelics is not new. People have been using it for thousands of years. And for some reason, 50 years ago, some government decided that this was not something they wanted people to take because it was a little bit too mind opening and a little bit too creativity expanding, right? Let's say it like that. But what's interesting is that we now rediscovered things we knew already in the 60s and 70s, which is that psychedelics not only makes you more creative, it also helps you solve a lot of your personal psychological distress and traumas by giving you perspective and by giving you more plasticity. And I think that this is like so important, especially today when you look at the mental health crisis that we're going through. So the first generation of psychedelics were pretty much like, pick up something in nature and eat it and see what happens. It's not very precise. That would be the equivalent of like penicillin as an antibiotic initially. You just take it from a plant, it does a job, but it also kind of does a lot of things you don't want it to do. New forms of psychedelics, now that people understand how the receptors in the brain work, what effects are being produced by which combination of drugs, you can start having precision psychedelics. You can start having like, okay, for that person that has this particular psychological issue to deal with and that particular pattern, what we really want is to provoke a sense of self-confidence and joy and laughter. But we don't want them to have visuals, or we don't want them to have like, loops in their brains of thinking. Well, you can design psychedelics to do exactly that. And I think that this is going to be the equivalent of modern antibiotics versus penicillin.
It's really interesting, especially considering how neuroplasticity, after 2 years of age, it starts to rapidly decline with like synaptic pruning, just so that we're able to facilitate long term memory formation. So it would be really interesting to be able to kind of return to that state of neuroplasticity to a certain extent. And
Or I'm not sure it will be as plastic as when you're a kid, but at least it will
yeah,
be less rigid than as you are as an adult.
right. Yeah. Hopefully not, because that would be a little too intense. But just the rate of learning is just incredibly astronomical when you're growing up. There's just so much input coming at you, and somehow we manage to process it without getting overwhelmed. That's pretty amazing. How do you envision our society changing from a transhumanist perspective? And what does it mean to be a transhumanist?
We're already all transhumanists, right? The first time a human picked a stick to grab a fruit on a tree, what they've done is they've extended the length of their arm to basically do something that they biologically couldn't do, which was reach the fruit. And this was the first form of technology, and it was also the first form of transhumanism. So I think technology inherently is about transcending biology. It's just that up until now, technology was a very external thing, right? We didn't really incorporate technology internally. We didn't really have like, well, we're not cyborgs, right? But again, this is changing. The more we start fixing ourselves inside, whether it's in your consciousness or in your body, the more we start to become, I would say, intertwined with technology. And so what used to be a stick will be an extendable arm in the future. And so I don't think there's going to be a point where we're going to be like, oh, we're transhuman. I think, there's going to be a point where we're going to be looking back saying, huh, interesting. Everybody's a cyborg. When did that actually accelerate? And I think it accelerated now. I'm convinced that, the global pandemic we had recently, that made people realize how fragile we were, right? And how submissive we were to viruses and to nature in general, right? And I think, you could either take that as a sign of, well, there's nothing we can do. If a virus wants to wipe us out, they can wipe us out. Or you can take it as a sign of, holy shit, we have to double down on science to make sure this can never happen again. And I'm in the second camp. I'm in the camp that doesn't want to be limited by biology. I don't like the idea that population can disappear overnight because we didn't have a solution. So I think, yeah, we should invest more in technology so that we have more solutions to more problems and that we can avoid a global catastrophe in the future.
So, prosthetics are a very obvious manifestation of body augmentation, but how do you envision transhumanism as informing efforts to extend our health span, not just our lifespan, but our health span and the number of years that we're able to live free from disease? Because, some scientists hypothesize that the maximum human lifespan is 150 years. Do you think that that is possible and that it's just a matter of limiting harmful exposures and that we're just like leaving these years on the table? Or do you think that there's something that we fundamentally need to augment in order to reach this milestone?
Well, think of it like a car. If you run your car in a treadmill in a lab, it could run for hundreds of millions of miles. Who knows, right? It's the same thing with a human body, right? If your human body is a car, and you're just running it in the optimal conditions, it can go for very long. Unfortunately, it's never the optimal conditions, right? There's always going to be something that you're not going to know. You're going to cross the street and someone's going to run you over, right? Like it could be a disease and a virus that just messes up all of your metabolism for years, right? Like you don't really know what's going to happen. So you need to be able to fix it as well. You need a garage for your body. You need someone to go in and basically make sure that you can replace pieces which are broken, and you can make sure that rusty things are being de-rusted. You need to do that to your body as well. And I believe that, as long as you take care of your car, you replace the parts when it's broken, and you make sure that, it's never misused, well, it's going to run forever. Same thing goes with the body. So I don't know if we're limited to 150 years, but we're only halfway there in terms of lifespan anyway. So, getting from 75 or 77 in the US to 150 would be already a huge improvement. So let's start there.
Definitely. I think one argument that potentially might differentiate us from vehicles would be that idea that human systems are somewhat anti-fragile, that they sort of require some amount of stress in order to keep functioning at optimal performance. And, of course, like you're saying, you need energy to maintain and repair structures. So necessarily, if you're seeing a breakdown in some process, that would imply that there is some deficiency in energy metabolism. But how do we perhaps balance, the need for physical stressors while making sure that we're not kind of going too far off the deep end when we're causing permanent damage? And can technology help us gauge where that
Right.
threshold is?
Yeah, possibly. I think, like quantified self and monitoring everything you're doing for sure will help. I'm a big quantified self guy, right? Like I've been doing it since 2010. And I think I've tracked more data about myself than any normal person. I don't know, maybe I'm not normal, but I consider myself to be normal at least. And what I found about this data, which was really amazing, is that it was very difficult to analyze. Too much data is very difficult to look at. So we need more focused monitoring of our health. Think of it like a hierarchical system. There needs to be some high level monitoring that's done 24/7 all the time. Maybe your blood pressure, maybe your heart rate or whatever. And whenever something is out of whack, then you need to go deeper and to figure out that thing. Because usually it's very rare that you're going to die from something that you haven't felt at all up until that point, right? There's always going to be a moment where you feel absolutely terrible, where your vitals are going to go weird, where you're going to have some kind of like physical manifestation or psychological manifestation. And that's the only way to really scale it, right? Eventually. Having said that, quantifying and tracking everything is also very tricky because it puts you in a state where you're overconscious about everything. And that in itself can be very detrimental to your mental health. It can make you severely hypochondriac, which means that eventually you can even manifest symptoms literally by thinking about it too much. And it happened to me at some point. I was tracking so many things that, like, my finger would hurt. I would freak out. I'd be like, oh my God, what the hell is happening? Why isn't my data telling me why my finger hurts? Guess what? It doesn't matter that my finger hurts. Maybe I just bumped it in the door without paying attention. Right. And so I think, there's a balance we need to find between quantifying things and monitoring things and not becoming crazy, right? Because of it.
I think that's an important distinction to not let ourselves get completely consumed by the metrics. But I guess that also ties into that ubiquitous computing concept that you developed that hopefully it'll just kind of run in the background one day and we won't have to
Yes.
consciously
If
be
it's
processing.
passive and you don't have to be conscious of it, then that's great. That's a very different story, right? Like, I'm wearing this Oura ring, for example. I'm not conscious of it. Like I see it on my finger, but it kind of looks like a ring and I wear rings anyway. So I don't really pay attention to it. Do I check my things? Yeah, I check it. Why do I check it? Because I kind of like to improve them, right? Does it freak me out when I wake up one day and my HRV is really low? Of course it freaks me out, right? But most times I don't think about it because it's passively doing its job. If I was to monitor actively and write down on a piece of paper myself everything I was doing, I would go crazy, right? And so I hope eventually that we'll have more of those things, right? Like that's actually a very good example of technology disappearing. Like it blends in with very common thing you don't think about.
That would definitely make things a lot less stressful, no doubt. I wanted to transition really briefly into your interest in geoengineering for climate change. Tell us a little bit about how that has the potential to help us get closer towards some of our climate change goals.
I haven't given enough thought about that to give a formed opinion yet. I'm interested in it in the same way I'm interested in, biotechnology. I'm interested in technology and how technology could be used to solve everything. Health, privacy, why not environment?
Makes sense. Yeah, it's quite transferable, the
Yeah.
concept.
Just don't know if it's a good idea, right? I haven't looked into it enough yet. You can do a clinical trial on 10,000 people. You'll still have 6, 7 billion more. There's only one planet. So how do you do a clinical trial on a planet? Until we have that answer, it's going to be difficult. Maybe a simulation, by the way. Maybe we need to have a very good simulation of the planet to conduct experiments. The same way AlphaFold can predict protein structure and you can do computational experiments in protein design and interaction. If we could have something similar for the planet, which by the way, I'm sure a million people are working on right now, then it would prevent us from doing like a real scale experiment, which again, arguably is very scary.
Yeah, the ethics would definitely be something to piece apart there.
Yeah. Well, if you mess up, that's it. So you only have one shot.
What do you think about terraforming? Because, some people are sort of this opinion that whatever happens to Earth, we can just somehow colonize Mars and terraform. I'm a little skeptical personally because, well, for one thing, we're adapted to life on Earth. Like our circadian rhythms are driven by our environment. And so the atmosphere of Mars, for example, would not provide that same feedback to our systems. But
Yeah.
do you think it's possible for our species to live on a different planet
Well, I
successfully?
mean, unless you're worried about Earth like exploding from an asteroid impact or something like that, I never really understood why people want to live on a different planet. If you're going to go to the trouble of creating, like a hospitable environment on a planet where you cannot live, why not do that on Earth in the first place? Right? At the end of the day, like if you're leaving Earth because the environment is messed up, it's not going to be better on Mars. So you're still going to have to fix it there as well. So I don't know, like maybe I should read more about that, to be honest. It's just so far, I would much rather us fix this planet and stay here because it's kind of cool, right? I like it, than go somewhere else.
For sure. Kind of evokes those messages that Carl Sagan would often tell us about in Pale Blue Dot, just that we have this responsibility to one another and to the planet because it's the only home we'll ever inhabit, more than
Yeah.
likely.
It's the only one I want to inhabit myself, at least.
Yeah, makes sense. Well, thank you so much for your time and for being with us and sharing your insights. We really appreciate it.
Well, thank you for having me and hopefully speak another time soon.
Definitely. Thank you. You can find the show notes for this and all other episodes linked in the show description. You can also review the show on Apple Podcasts, Spotify, Castbox, or Podchaser. Thanks so much for tuning in. Until next time.